All right, today we're going to talk about a totally different way of thinking about databases, specifically for Amazon DynamoDB. Now, if you come from the world of traditional SQL, you're going to have to flip your brain around a little bit. We're shifting away from designing for flexibility and moving towards designing for just raw, incredible performance at a massive scale.
So think about how you usually build a database, right? You map out all your data, you normalize everything, you build your tables and your schema, and then you figure out how you're going to ask it questions. Well, what if I told you that with DynamoDB, that entire process is completely backwards?
And this is really the heart of it. You've got two totally different philosophies here. On the one side, you have the relational world, SQL. You build this perfect, beautiful schema first, which lets you ask almost any question you can dream up later. But the catch? At huge scale, those flexible queries can really start to slow down. But then on the other side, with DynamoDB, you start with the questions you're going to ask, your access patterns, and you build a schema specifically to answer those questions, and to do it lightning fast. You're basically trading some of that Ask Anything flexibility for just insane speed.
So what exactly is a NoSQL database anyway? Well, at its core, it's just a system that doesn't use those rigid tables and rows that you're used to. Instead, it uses different ways to organize data, like the simple key-value pairs you see here. The entire point, the whole philosophy, is that it's purpose-built. It's designed to handle very specific types of questions at a speed and scale that traditional databases can really struggle with.
Look, if there is one thing, just one thing, you take away from all this, it's got to be this quote right here. This is the absolute golden rule of DynamoDB. Knowing your application's use cases and the questions you need to answer before you even start isn't just a nice-to-have, it's everything. Your queries define your schema. Full stop, not the other way around.
Okay, so when we say know your questions, what does that actually look like in practice? Well, it pretty much boils down to these three things. First, data size. Just how much stuff are you going to be storing and asking for in a single request? Second, data shape. How do you need to organize that data so it perfectly fits the questions you're asking? And third, data velocity. What's your peak traffic going to look like? How many requests per second are you going to get hammered with? You have to have answers for these before you write a single line of code.
And all of that thinking about the size, the shape, the velocity, it all leads you to what is probably the single most critical decision you will make: choosing your partition key. Now, this is not just some random ID. The partition key is what DynamoDB uses to physically spread your data out across all of its servers. You get this right, and you unlock that incredible performance. But if you get it wrong, oh boy, you're looking at a huge bottleneck for your entire application.
So let's make this real. A good partition key, something like a user ID, is great because every user's activity is spread out. It distributes the workload. A bad partition key, like the date something was created, is a disaster. Why? Because all of today's new items, all of that write traffic, is hitting the exact same spot. It's the same with something like a status code. If you only have a few statuses, you're creating just a handful of hotspots that are going to get absolutely slammed with requests.
And that right there brings us to the number one ultimate goal of this entire design process. You are doing all of this work to avoid hot partitions. A hot partition is a single piece of your database that's getting way more than its fair share of the traffic. It gets overwhelmed, it starts throttling requests, and it can bring your whole app grinding to a halt. The name of the game is to spread that workload out as evenly as you possibly can. Okay, so once you've figured out how you're going to access your data, the next big question is about the volume. Is your traffic nice and steady, like a predictable hum of activity, or is it all over the place, totally unpredictable with massive spikes and long quiet periods? How you answer this is going to directly impact how you manage and, how you pay for your database.
And that's because DynamoDB gives you two main choices. First, you have on-demand. This is perfect for spiky, unpredictable traffic or brand new apps where you just don't know what to expect. You simply pay for what you use, request by request. Then you have provisioned mode. This is for those steady, predictable workloads. You tell DynamoDB exactly how much capacity you need ahead of time, and you pay for that amount, whether you use it all or not. It takes a bit more planning, but for the right kind of traffic, it can definitely save you some money.
So how do you pick? Well, here's a fantastic rule of thumb from the source material. If you look at your workload and find that your average utilization of that provision capacity is less than about 35%, then on-demand is very likely going to be the cheaper option for you. At that point, you're basically paying for a lot of capacity that's just sitting there doing nothing when you could just be paying for the spikes as they happen.
But let's say you do go with provisioned mode. The main dial you can turn to optimize your costs is called target utilization. Think of it as a balancing act. If you set a higher target, you're running leaner, which means lower costs because you have less wasted capacity. But it also means you have a higher risk of getting throttled if there's a sudden spike. A lower target costs a bit more, but it gives you a bigger safety buffer. The goal is to get that number as close as you can to your actual usage without causing any errors.
Okay, time for a lightning round. Let's fire off 3 really smart, cost-saving techniques that come directly from thinking in this NoSQL way.
First up, time to live, or TTL. This feature is just fantastic. You just add a timestamp to your data that says, delete me after this time, and DynamoDB automatically takes care of the cleanup for you, for free. It's a true set-it-and-forget-it way to keep your tables from getting bloated and to save a ton on storage costs.
Number 2, get to know sparse indexes. Okay, this is really clever. Imagine an index in a book that only listed the pages that had, say, a map on them. That's a sparse index. It only includes entries for items that actually have that specific attribute you're indexing. So if you want to find all your open support tickets, the index only contains those items. This makes the index incredibly small, which means it's super fast and super cheap to query.
And finally, be a detective. Go into your CloudWatch metrics and hunt for resources that aren't being used. Look for tables or indexes that have had 0 reads or 0 writes for the last month. If you find one and it's truly not being used, it's just a vampire slowly draining your money on storage costs. So back it up and then get rid of it.
And so we end up right back where we started. This whole mental model, this whole way of thinking, it really just boils down to one simple question you have to ask yourself. Are you designing a system for flexibility, where you might need to ask any question under the sun? Or are you designing for massive scale, where you need to answer a very specific set of questions for millions of users in just a few milliseconds? The answer to that question tells you everything you need to know. Thanks for tuning in.